Hello everyone, this is the Circular Economist here, bringing you another video. I am an expert in the circular industrial economy, sustainability, and specialized in environmental education and complex economic system theory. I wanted to give you a short disclaimer in the beginning. This video is for educational purposes only and not to be seen as anything else. In this video, we're going to talk about the Great Acceleration and the planetary boundaries. This is important to give you all insight into overall system trends that are the consequences of the topics already discussed. This allows us to really frame the environmental macro picture of the reality of the facts and figures of Earth's natural system. Why? Because we need to have a realistic view on the state of the resource use and connected environmental parameters of today before we can discuss the circular economy and its impacts and improvements on those parameters. In short, we need to know where we are in order to know where we're going. This will also make it way easier for you to all understand the concepts of this new circular systems framework. So, the Great Acceleration. What is the Great Acceleration? I would like to give you all insight into global parameters, the current state of systems in different sectors. For example, socioeconomic trends that we have on the left side, but also terrestrial or Earth system trends that we have here on the right side. This chart and also this map is termed the Great Acceleration. And now, what does acceleration mean? Because we're talking about very global subjects here, and I think it is always important to define the terms as precisely as possible. So what does acceleration mean? First, we need to know how velocity is defined in a mathematical context. So we have two parts. We have velocity and acceleration. Velocity is described as the change in position within a certain time. If I'm going from A to B, then this will take me a certain time. The units of this are, for example, 4 kilometers per hour. Now, if I go from A to B, I will do that, for example, with 4 kilometers per hour. So in 1 hour, I would have gone 4 kilometers. Acceleration then can be ultimately seen as the change in velocity in a certain unit of time. If I start at point A and start out with a certain speed, and then over time increase that speed while going to B, I'm accelerating, which subsequently means I will reach my destination faster. So I start out with 4 kilometers per hour, then I increase that speed to 6 kilometers per hour, then I increase that speed, for example, to 8 kilometers per hour. I am accelerating. So the description of velocity and acceleration, of course, is not limited to going by foot or driving a car, but is applicable, for example, to the extraction rate of materials but also to the construction rate of dams, for example. We are not going to dive further into derivatives and calculus because I think you get the picture, but this is what is required to understand the following chart. In this chart, we can see the current state of socioeconomic trends, but also Earth system trends or terrestrial trends. We can see that, for example, on this left-hand side, socioeconomic trends, the global population is increasing, real GDP is increasing, primary energies, but also fertilizer consumption exponentially increasing, the building of dams exponentially increasing, although flattening at the top, water use increasing, paper production, but also transportation, telecommunications, and international tourism. So the graph or the curve actually looks almost the same. there are different kinds of graphs, but they always have almost the same curve, right? So that's almost always a perfect exponential increase. Now, the increase is different. We can see here that the increase from 1915, for example, to 2010 is different in the building of large dams, for example, than, for example, the international tourism chart, right? So I'm going to go ahead now to Earth system trends, and we're going to discuss what that means. But bear with me here. The Earth system trends, as we can see, the chart is also exponentially increasing. Atmospheric concentration in parts per million of carbon dioxide increasing, nitrous oxide, methane increasing, stratospheric ozone, Earth's temperature or surface temperature, deacidification in oceans, marine fish capture, coastal nitrogen, domestic land, or terrestrial biosphere degradation, but also tropical forest loss increasing. This means, and this is the answer why those graphics or those curves almost look the same in every chart. This means that the speed or velocity in those parameters is changing, therefore accelerating. Therefore, we talk about the great acceleration. Not that we are using a lot of materials and do things with them, but that we are using more and more and more in the same units of time. Same with the terrestrial parameters. Not that there is more CO2 emitted in a given time with a constant rate of change, but there is more and more and more CO2 in the atmosphere in the same units of time. So, for example, from 1950, the increase to 1980, that's about 315 parts per million, to 1980 to 330 parts per million. Now in the next 30 years, the increase is 60. First the increase was 15 and then it's 60. From 330 parts per million to, in 2010, 390 parts per million. So the increase is changing, right? So in the same time, for example, 30 years, 1950 to 1980, and then 1980 to 2010. That's 30 years and 30 years. But we have an increase of 15 and then an increase of 60. So this is important to keep in mind here. And why is that important, and where does this lead? We all know that we have finite resources on planet Earth, and the question where this leads is a very good one, because nobody really knows exactly. And this is what leads me to the next chart to really frame the macro picture. This is the chart of the planetary boundaries. Now, what are the planetary boundaries? The planetary boundaries concept is given to us from the Stockholm Resilience Center from the Stockholm University. Planetary boundaries concept presents a set of 9 planetary boundaries within which humanity can continue to develop and thrive for generations to come. So, 2009, former Center Director Johan Rockström led a group of 28 international renowned scientists to identify the 9 processes that regulate the stability and resilience of the Earth system. This is the updated version of the planetary boundaries. Those boundaries, as stated, represent operating zones for humanity in which we as a collective should operate to be in balance with Earth's natural biochemical cycles, but also, for example, maintain biodiversity and so on. For example, this biosphere integrity, formerly biodiversity, but updated to biosphere integrity, functional diversity, genetic diversity, climate change, novel entities, stratospheric ozone depletion, atmospheric aerosol loading, ocean acidification, biochemical flows, biogeochemical flows, freshwater change, but also land system change. And inside here, we have the safe zone. So safe operating space for people and a resilient planet. The red parts here is where there is the danger zone. So we have a safe zone and we have a danger zone. And where it says it's blue, it says no global quantification. So we have no quantification in data and also missing global data on that. We can see here that land system change, for example, is already in the danger zone. Freshwater change, for example, green water, the danger zone. But the most important thing is biogeochemical flows. So the phosphorus cycle on planet Earth, but also the nitrogen cycle or nitrogen flows. This is the state of those 9 operating zones, and this, together with the other charts I have shown you, will enable you to acquire knowledge on the future concepts of the circular economy and the improvements it aims to achieve. This is also to show you that the topics of sustainability and the lack thereof in our current linear systems is not just a green, woke, evil agenda or something else, or just an idea from someone's grandmother or grandfather about how the world works, but the dedicated work and attentive contemplation of the natural world by thousands upon thousands of scientists, researchers, politicians, business leaders, and others to make sense of our material world through measurements of biochemical feedback loops and dependencies in complex systems. I'm trying in my videos to bring you insight into a very complex subject with many gears as best as I can. Those subjects and gears broken down into the simplest form so almost everyone can understand why society needs a drastic shift in the way we extract, produce, distribute, consume, and reintegrate resources to maintain the quantity and quality of stocks in the natural world. We only have one planet, and it is time to rethink the way we live and how we think about the nature in general. It is important for all of us to raise our awareness, to establish an attitude of caring for nature and the things she provides. After all, if we're sad and depressed, it is nature that provides us with the healthiest things, right? Like clean oxygen to breathe and sunlight to sustain our physiological processes and mood. In the next video, we're going to start talking about the circular economy and the fundamental principles of circular resource flows. If you need additional information about the topics or want to book a training for your company to reduce your cost in terms of energy usage and material usage, you can write me an email and we can make an appointment. Hit the like and subscribe button so that you're notified when I drop the next video. With that said, I wish you all the best and see you all in the next video.